In this video, I'm going to be talking to you about working with table views. A table view is used to contain a set of dynamic data. It's a one-dimensional table which is a subclass of the UI scroll view. If you want more than one dimension, you would use a navigation controller and then drill down to maybe another table view containing the next set of data. The important thing is we can customize our table using two protocols. The first one is the data source protocol, which controls the data supplied to the table. And the second is the delegate protocol, which determines how the data is displayed in the table. The key benefit of working with these protocols is it's very efficient to handle very large sets of data. So when we use a table view controller, we arrange content into a one-dimensional table, and we can choose whether we have a plain or a grouped style. And that's determined by the table view properties. The plain style, the items go full left to right, and you have a very simple layout. In the group style, each section of the table is in a separate block, separated with some white space from the one above and below. So let's look at some of the table view elements that we deal with. And these are the same whether it's a plain or group style. As you can see, each row is called a table cell, and table cells are arranged into sections. And each section can have an optional section header and or a section footer. When you create your table views, you can choose one of a pre-defined set of cell styles. The standard one is called Basic, which contains a title text. Then we have three variations which have a title and detail. We have a right detail, a left detail, and we have a subtitle variant. But you can also create your own custom cell styles, and we'll come on to that in another video. So let's have a look at how we create a table view controller. So far we've worked with view controllers. We drag a view onto the storyboard and then we assign it a view controller subclass. It works in a very similar way. We take our table view controller and drag it out into the storyboard, and then we create a new Objective-C class, but this time we create a subclass of UI table view controller rather than UI view controller. And this gives us the methods that we need to be able to implement the data source and the delegate. Obviously, we need to make sure we assign the custom class to our view, and then we can start looking at how we supply data to our table view. The important thing is data is only supplied to the table view as it needs it. And if you think about a table view on a phone screen, you can only see about 6 or 7 rows at any one time. So which means the view will only request the data it needs to maintain the view. When the requests are made, the view controller can ask 3 questions. The first question it asks is how many sections are there in this table, because that will determine how the table is laid out. And that returns an integer value. The second question it asks is, for a given section of my table, how many rows should there be? And again, that returns a simple integer value. The third question is a bit more detailed. The third question says, what should be displayed in a specified cell in the specified section? So it might say, what data should be displayed in cell 2 in section 0. And this returns a UI TableView cell object. And the clever thing about this is, when you scroll up and down, it recycles the TableView cell objects rather than generating new ones. So at any one time, you've probably only got 7 or 8 TableView cells in memory at once. So here's an example of a data source. And in this example, I'm going to display the word test in 5 cells. And there's only got 1 section. So if you look at it, the first question says, number of sections in table view, I'm returning 1 because I want 1 section. Number of rows in section, I'm simply returning 5 because I want 5 rows. And in table view self row at index path, I'm simply setting the cell text label text property to test. But let's have a look at this third method in more detail. You can see that I've got a cell identifier. When I create my prototype cell in my storyboard, I must give it a cell identifier. In this example, I've called it cell, so it retrieves the cell identifier. It then creates a new UI TableView cell. It says DQ reusable cell with identifier, the identifier for index path. Now the cell identifier is my NS string cell. The index path is an interesting structure. The index path contains a section integer and a row integer. And all I'm doing in this example is I'm simply setting the text label in my cell to test and returning the cell. And this is how it's going to look. What we need to do really though is have some sensible data in our table view. So we're now going to look at how we use a mutable array as a data source for our table view. Now there's two ways we can generate data for our table view. We can use a mutable array, or we can use something called core data, which is not being covered in this particular part of the module. So to start with, I'm going to create a private NS mutable array property in my implementation file, and I'm going to synthesize this. So I've now got an NS mutable array property called items. And in viewDidLoad, I'm going to allocate my mutable array. I'm going to add two objects to it, so I've got something to display in my table view. So let's revisit those three data source methods. So I'm only going to have one section, so that stays as one. But for number of rows in section, that's based on how many indexes there are in the NS mutable array. So I return self.items.count, which tells the table view how many items are in the NS mutable array. And to display the correct text in my cell, I specify the text property as self.items, object at index, okay, and then index path dot row, because the index path property section will always be 0 because there's one section. The row will tell this method which row I want to retrieve. So when it displays the first row in the table view, the index path.row property will be set to 0. So we want to return the first item in the NS mutable array. When it tries to display the second cell in the table view, the index path.row property will contain the value of 1. So we want to retrieve index 1 from my NS mutable array. And this is how it's going to look when we're finished. And as you can see, it displays both indexes in the table view. Now let's have a think about the table view headers and footers for a moment. If you remember, we can display a header and footer for each section in our table view. And it's always a good idea to add these two delegate methods to our table view. The first one is TableView title for header in section, and it passes the section we want to display the header for, and TableView title for footer in section. And if I return nil, it doesn't display the header or footer. But if I detect the section I'm in, I specify the value I want and return it, it will then display the correct title for the header and the footer. So we've now looked at how we can display data in our table view and how we can add headers and footers. I'm now going to talk about how we trigger segues from our TableView cells, because often we want to click on a cell to trigger a segue to a different view. To do this, we can simply control drag from the TableView cell in the storyboard to the view we want to load. But then we need to detect which cell has been clicked on to determine what data to pass. So the key delegate method here is something called didSelectRow at index path. The key delegate method to determining which cell has been clicked on is the TableView didSelectRow at index path. And this delegate method has an index path parameter. And the index path, of course, contains a section and a row integer. So as soon as we click on a cell, we can immediately use this delegate method to figure out which cell's been clicked on. And then we can launch the correct segue. So of course, once we know which cell's been clicked on, we can do more than that. So for example, we can add a checkbox to a cell. Because if we know what row's been selected, and we know the table view. The second parameter we get passed is the table view. So with a combination of the table view and the index path, we can do clever things like, for example, we could add a checkbox to our cell. Because what we can do, the way we do this is we create a UI TableView cell object by calling the self-row index path on the TableView parameter. And then we can toggle it, we can set the accessory, and then we can set the accessory type for the cell. And the last method, which I'm showing you, is deselect row index path, which means after you've clicked on the cell and it gets highlighted, the highlight will fade away. And if we call deselect row index path, it removes the highlight in an animated fashion. And all the accessory types are read-write. So for example, what we could do, we could detect what the accessory type currently is and change it based on that. So in the example I've got, if I tap on a cell that's already got a check mark, it will remove the check mark. But if it hasn't got a check mark, it will add the check mark. So I can toggle the check mark on and off using this particular if statement. As we found out when we talked about segues in the previous lab, there's this special method called prepare for segue. Now, prepare for segue is all well and good, and we can trigger the segue, but we need to determine which cell's been clicked so we can pass the correct data to the next view. To do this, if we have a table view in our view, there's a property called self.TableView which returns the TableView object. And then we can call the index path for selected row, and when we call that, we can retrieve the section and the row. And then we can work out which cell's been clicked, and we can send the correct data to the next view through the segue. I'm now going to talk to you about toolbars and bar button items. A toolbar is a very useful facility to add buttons to allow the user to interact. When we work with navigation controllers, it's very useful to have a toolbar. Now, when we add a toolbar, we specify the toolbar we're adding to the navigation controller, which means that every view inside that navigation controller also gets a toolbar. And this allows us to create a consistent user interface. However, for each toolbar, we can add and remove items within the individual views. So all the views will have a toolbar, but the buttons in the toolbar will change depending on which view is being displayed. And we add a toolbar using one of the properties of the navigation controller. If you look at the simulated metrics, you can specify status bars, top bars, and bottom bars. And for the bottom bar, we specify opaque toolbar. And that gives us a toolbar on every single view within the navigation controller. Once we've added the toolbar, we're going to add some bar button items by dragging and dropping the bar button items into the relevant toolbars. But it'd be very useful to have a single IB action to service all of the different buttons. And we can do that by creating the IB action by dragging and dropping across for the first one. And then you drag from the circle across to the additional items. Once you've done that, you can use if statements to determine which bar button item has been clicked and respond with the appropriate code. We can add and remove bar button items using the storyboard. Also, we can add and remove items at runtime. Once we've added a toolbar to a view, we have a special property called toolbar items, which is an NS array. And this contains an array of bar button items, which means we can add new ones and delete existing ones. But to do that, we have to create a mutable copy of the NS array, because obviously NS arrays can't be changed, they're mutable. We then add the items that we want to, remove the items from our mutable copy, and then we assign that as the new toolbar items array property. Next, we're going to look at how we add new TableView cells. So for example, if you were creating a shopping list, it's very important to be able to add new items to the shopping list. So to add a new TableView cell, it's a two-step process. We need to add the item to our data source, which is our mutable array, and then we need to tell the TableView to reload the data from the array. And it's very simple. We obviously add an item to the mutable array using add object, and there's a special method of the TableView which is reload data. which forces the table view to reload the data from the data source. You can do this automatically once you've added items, but you've often seen the facility where you can pull down and release on the table view to load new data. And this is called a UI refresh control. And this is very useful when the data is coming from an external source like a web service. The first thing you have to do in the table view controller is enable the refreshing mechanism, the pull down mechanism. And at the same time as enabling it, you can also specify the text to appear next to the animated circular indicator. And what we then have to do, we have to tell the refresh control which method to call when it gets triggered. So in the view.load, we might say self.refresh control, add target self for action reload data. For control events, UI control event value changed. And then we simply create a method that matches the action we specified. We call the reload data method on the table view, and then we must call end refreshing on the refresh control, otherwise it will keep going forever. Next, we're going to look at how we delete TableView cells. To delete a TableView cell, we use the built-in mechanism that iOS provides. If you swipe left on a cell, it should reveal a delete button, and then you tap the delete button and the other rows animate up to fill the space. And if we stick to the standard UI mechanisms, people will find it very easy to work with our application. What's very important though is it's a two-step process to delete a row, because we have to delete the row in the data source and we also have to remove the row from the table view. If we don't do them both carefully, we end up with an internal consistency error. So we're going to wrap the two actions inside a transaction, which basically means if any of those two actions fail, it rewinds back to what it was like before, so we don't delete anything from anywhere. So for this to work, we have to implement two delegate methods. The first determines which cells are editable, and the second one carries out the delete process. They're already in your implementation file, they're just commented out. The first method is called TableView can edit row at index path. And if you want a cell to be editable, you have to return yes, but it also allows you to make certain cells non-editable if you wish. And the second method is called TableView commit editing style for row at index path. And there's an if statement which says if the editing style is editing style delete, else if editing style equals editing style insert. We're going to insert our code into the first part of the if statement. So let's have a look at the code we add. First of all, we begin updates, which starts a transaction. We then remove the row from the NS mutable array. And then we delete the row at the index path with animation. And finally, we end updates, which completes the transaction. The final thing we're going to talk about is how do we reorder TableView cells. Now, as with deleting, there's a mechanism for reordering. We have a button called Edit at the top right-hand corner, which we tap. The button then changes its text to Done, so we can finish the editing. And in editing mode, we can drag and drop the cells into different places by clicking on the right-hand side. For this to work, we have to add a bar button item to the top of our screen. This has to toggle the editing mode of our table and also toggle its own text, so it changes from edit to done. So this is the action for our bar button item. And as you can see, we check to see if editing mode is enabled. If editing mode is not enabled, we want to set the title to done and enable editing mode. Else the title becomes edit and the editing mode is switched off. And if you implement that, we then have to implement two delegate methods. One, the first delegate method determines if the cells are reorderable, and the second delegate method handles the reordering of the cells. So once we've enabled the editing mode, there are two methods that we need to implement. The first one is called TableView can move row at index path, and that returns yes or no, and that determines whether the reorder graphic appears on the side and we can move them around. The second one is called TableView move row at index path to index path. And this is interesting. It has these two parameters, and both parameters are index paths. The first one is where the cell currently is, and the second one is where we want the cell to move to. So when we call this method, TableView move row at index path to index path, what we're doing, we're moving the items in the data source. So I'm retrieving the index from the items NS mutable array. I'm then deleting that from the array, and I'm then inserting that item into the correct index back in the array, and it will automatically update the table view when that's done. So I've now shown you how you can create a table view, how you can pull data from a data source into a table view, how you can add, remove and reorder items, and that should be enough to be able to complete the lab task for Lab 5.